All right, the quiz review. You have these formulas up top. Hope you remember a few of the basic things. You also have your blue packet to use. All right, I'm not going to flash back and forth. You see, use the chart. I think we've used enough. This was be a review. So we're going to use our chart A. Make sure you're paying attention whether it's a positive z-score or negative z-score side. All right. So to the left of Z. First off, I'm going to go through and look at any of the ones I have. Whoops, you're not going to do that. Anything that says to the right, because that's going to remind me that this is going to be a 1 minus. All right. So all the rest of these first four are to the left. So I'm just going to look up 0.33. All right. So you go down, find 0.3 on the left side. And go over, remember that first column 0, so it's going to be 0.30, 0.31, 0.32, 0.33, and you'll find 0.6293. And you can leave it like that. Yes, it is 62.93%. I'll accept either one. Okay, left of 2.55, still on the positive side. Remember, go down to 2.5 and go over 6 columns. Because that's 0, 1, 2, 3, 4, 5. And you're going to get 0.9946. Notice here we have a negative number. So you're going to go down the left side to negative 0.2 and go over 8 columns to negative 0.27 and get 0.3936. 1.72, go down the left side to 1.7, go over 3 columns to 1.72, and you're going to have 0.9573. All right. Number 5. So in this one, remember, you have to look up negative 1.6, I'm sorry, 1.68. And when you look up 1.68, you get 9535. Which you're going to subtract from 1. And that's going to give you 0.0465. Okay, number 6, to the right of 0.12. So you look up 0.12, so 0.1, go over 3 columns, and that's going to be 5478. Okay? And then when you subtract those two, you're going to get 0.4522. Okay, between negative 1.64 and 0. So we're going to get our two numbers for negative 1.64. So negative 1.64 is 0505. And 0 is obviously 0.5000. And we're just going to subtract 0505. And that's going to give us 0.4495. All right, negative 1.55 and 1.04. So you're going to go to negative 1.5 over 6 columns, and that's going to give 0.0606. And then 1.04, so 1.0 over 5 columns, 8508. And all you're going to do is subtract these two. 0606. And that's going to give me 0.7902. Okay, number 9. Same concept, between 0.05 and 1.71. So 0.0 is just the very top, go over 6 columns, that's 0.5199. 1.71, 1.7, go over 2 columns, 9564. And then all we're going to do is subtract the 0.5199. I don't know why I wrote so many nines. Let's start over. 0.5199. And when you subtract those from number 9, you get 0.4365. Okay, between negative 1.96 and 1.96. Okay? So, negative 1.96, negative 1.9, go over 7 columns, and you get 0.0250. You go to 1.96, and you get 9750. That is a 5, not an 8. And that's not where the minus goes. Minus 0.20250. And when you do that, you get 0.95. 00. All right. Left of z and right of negative 1.5 and right of 1.5. So left of z, first off, of negative 1.5 is going to be 0.0668. To the right of 1.5 is going to be 1 minus, and then when you look up 1.5, you get 9332, which is 0.0668 also. Notice how these are the same. And you're basically just going to double it and get 0.1336. So when you're going left and right of basically the same number, okay, you can look up 1 and just double it. Okay, this one's different. You can't do that shortcut. So left of z, 0.64, is 0.7389. And then right of, which means 1 minus, we look up 2.16, 9846, which is going to be 0.0154. We're going to add those two together to get 0.7543. All right. Find the indicated probabilities using the standard table or the graphing calculator. Okay? What's the probability of z less than 1.28? Again, you're just using your table, looking at 1.28, and you get 0.8997. Greater than, so that's going to be 1 minus, so we're going to look up negative 0.74, which is 2296, and that gives us 0.7704. Okay, between these two numbers, so we're going to look up negative 2.15, that's 0.00, oh sorry, my bad. Yeah, it's between the two. So greater than negative 2.15, but less than 1.55. So negative 2.15 gives us negative 2.15 is 0.158. And 1.55 is 9394. And if we subtract 0.0158, we get 0.9236. Okay, so here we're looking in between 0.42. So 0.42 is 6628. And you practice looking these up on the table yourself. And then 3.15 is 9992. Subtract those. And you get 0.3364. All right, number 17. This is the one where it's the same number on left of the negative and greater than the right. So you really only have to look up one of these numbers. So if you look up negative 2.5, 0, it's 0062. And this is going to be the same thing on this side. So you can add it up twice or double it and get 0.0124. Okay, less than 0. Well, that's 0.5. Greater than 1.68. That's going to be 1 minus. So we look up 1.68. 9535. Which is going to give us 0.0465. We're going to add those two together and get 0.5465. Oops. Number 19, for the standard normal curve, find the z-score that corresponds to the first quartile. Okay, well that's, first quartile is 25%, or 0.25. So we're looking for 0.2500. So the closest ones are 0.2514 and 0.2483. This one has a z-score of negative 0.67. This one has a z-score of negative 0.68. I would accept either one of those answers. The best answer, though, is going to be to add these two and divide by 2 and get negative 0.0675. Or just tack 5 onto the smaller one. Okay, IQ tests are normally distributed with a mean of 100 and standard deviation 15. Individual score is found to be 90. Find the z-score corresponding to this value. Okay, so actual minus the mean divided by the standard deviation. That's going to be negative 0.67. And consequently, if we wanted to know the area probability for that one, that's right here on the previous problem. Okay, IQ test normally distributed with a mean of 99 and standard deviation of 11. Change the numbers up again. Well, the score was 109. Actual minus the mean divided by the standard deviation. And you get 0.91. Almost a whole standard deviation above. All right, lengths of pregnancies of humans are normally distributed with a mean of 268 and a standard deviation of 15 days. Find the probability of less than 250. Okay. Well, we'll take 250, the actual, minus the mean, 268, and divide by the standard deviation. That gives us negative 1.2. It didn't ask for the z-score, though. It asked for the probability. So we need to go to our table and look up negative 1.2, and that's going to give us 0.1151, or about 11.5% probability. Okay, 23. Airline knows from experience the distribution of the normal number of suitcases that get lost each year is approximately within a mean of 15.5, standard deviation 3.6. What's the probability of losing less than 20 suitcases? So actual minus the mean divided by the standard deviation. That's going to be 1.25. Again, though, it's asking for the probability, so we need to find the area under the curve. So we look up 1.25, get 0.8944, or 89.4%. Number 24. Blood pressure. There's your average, standard deviation, okay? 145 or higher is bad, so we're looking for greater than. So we're going to be doing a 1 minus in here. But let's first find our z-score. So 145 minus the actual score minus the mean divided by the standard deviation equals 3.13. So if you look at 3.13, it's going to be 0.9991. When you subtract that, you get 0.0009. Okay? Or 0.09%. Okay, 25. Assuming heights are distributed equally, there's your mean, there's your standard deviation. You need to be between 64 and 78 for the core, 500 mil on the list. How many would you expect to meet the height requirements? Okay, so there's a lot to do in this one. First off, we have to find out the z-scores for both 64 and 68. So actual minus mean divided by standard deviation. That gives us negative 1.79. And if we do the actual 78 minus 69 divided by 2.8, that gives us 3.21. Okay, so this z-score, this area, is 0.0367. This one is 0.9993. If we subtract those, we get 0.9626. Okay? And that's the probability. So we're going to take that, 0.9626, times the 500 soldiers, or wannabe soldiers, and that would mean about 481 should fall within that range. So that's a multi-step process. Gotta find out the z-score for the low and the high, area for the low and the high, subtract them, get the percentage, and then multiply by the number of people. What's the mean of the standard normal distribution and what is the standard deviation? Okay, well, the mean of a normal one is 0, and the standard deviation is 1. 27. Okay, so we're just going to put our information on here. 268 goes there, that's our mean. Standard deviation 15 days. So we're going to do our 1, 2, 3 lines, 1, 2, 3 lines, try to space them out. And then you're going to add 15. So 283, 298, and then 313. And over here we're going to have 253, 238, and then 223. And there's your breakdown. Now, it says, what about more than 270 days? Well, that's just going to be slightly right of the mean, and we're going this way. So, we're taking our actual score of 270 minus the mean divided by the standard deviation. That gives us 0.13. Now, that means we're going to do 1 minus, because we're saying greater than, 1 minus 0.5517, that's 0.13 looked up, so that's 0.4483, or about 44.8%. Okay? Number 28. Test scores in statistics class are normally distributed with a mean of 75, standard deviation of 6.4. You got an 85. Find the percentile for your test score. Okay, same calculation. Actual minus the mean divided by the standard deviation. That is 1.56. Look that up on the table, and you get an area of 0.9406. So that's going to be about the 94th percentile. Similar idea. Score of 73, the actual, minus the mean of 63, divided by the standard deviation of 5. That gives us an exact z-score of 2. Okay? Now we're also looking at 78. So actual score of 78 minus 63 divided by 5 gives us a score of 2. Sorry, 78 minus 70. What was it? I don't know what. Copied the wrong number, my bad. Okay? So they are the same. They are equivalent. They're both 2 standard deviations above the mean. Or the 98th percentile. All right, you need to purchase a battery for your car. Has a mean life of 6 years, standard deviation of 6 months. Battery B has a mean life of 6 years, standard deviation of 1 year. The batteries cost the same. Which should you buy? Explain your reasoning. Tend to use the empirical rule. Okay, we put battery A here and battery B here, and we draw our normal curve. And we put our mean at 6 years for both. Okay. Well, battery B, 1 standard deviation below is 5. And this is 2 standard deviations below. So if we look up 5 or greater, we're looking at greater than -2 standard deviations. And if we're looking at 5 or greater here, we're looking at greater than -1 standard deviations. So if we just look at our chart and look up -2, that's going to be 1 minus 0.0228, which is 97.72%. And if we do 1 minus 0.1587, which is -1, we're going to get 84.13% chance. So battery A has a higher chance of making it 5 or more years. Okay, 31. We have records showing that 21% of adults have seasonal allergies. Select a random sample of 200. Let Y be the number of individuals in the sample. So calculate the mean and standard deviation of the sampling. All right. Well, our mean is going to be 0.21. That's our 21% right there. And then the standard deviation is going to be that little calculation from the front page. 0.21, remember that's, you spent 21 cents on candy, pay $1, you get 69 cents back in change. And then divided by 200. And so that's 0.0288. So there's your mean standard deviation. Interpret standard deviation from part A. Okay, so in a sample, oops. It's supposed to be an R of 200. About 0.0288 deviate from the mean of 0.21. All right. Would it be appropriate to use normal distribution to model the sample? Yes. I just realized I made a mistake up here. This should be 0.79. Sorry about that. I typed it in right, I just wrote it wrong. Okay, so that's where I thought about this one. You're going to take P of 0.21 times 200. That's going to give you 42. And then 0.79 times 200. That's basically just doubled, so that's 158. Both of these are greater than or equal to 10, so we're good to go. Okay, 32. Last page. Okay, now we're going backwards. So we're looking for an area of 0.4325, and you're going to look on your Z table and get negative 0.17. 0.2, negative 0.84. 0.8485, that's going to be 1.03. Remember, you're just going backwards. You're trying to find 8485 in the table, and then go to the left column and up and find your matching numbers. Okay, P3, that's the third percentile. Okay, so that's going to be 0.0300. When you look that up, it's going to be negative 1.88. This is the 75th percentile. That's 0.7500. That's going to give you a z-score of 0.67. And this is the 40th percentile. So 0.4000. And that's going to give you negative 0.25. All right, and then this problem right here, all based on the same information. So we have our mean of 48 and a standard deviation of 3.5. Find the breaking distance that corresponds to negative 2.3. So this is just working backwards. So negative 2.3 equals x, we don't know the actual value, minus 48 divided by 3.5. And that's going to give us 39.95 meters. Okay? X minus, sorry, I forgot my 1.3 here. 1.3 equals x minus 48 over 3.5. And that's going to give us 52.55 meters. What is the breaking distance of the 95th percentile? Well, we got to look at 0.9500 on the chart. And that gives us 1.645. It's in between two numbers. So you're going to be slightly different if you use 1.64 or 1.65. I'm going to use this. Okay? So 1.645 equals x minus 48 over 3.5. And that's going to give me 53.76 meters. What about the third quartile? Okay, well you have to look up 75% or 7500. And that's going to be between 6.87 and 6.8. So I'm going to put 6.75. And remember, this is the shortcut formula that we had, so you can do it the way we've been doing it, or you can just take the standard deviation times the z-score plus 48 equals 50.36 meters. Same answer, just different way of doing it. You do what's comfortable for you. Shortest distance for 10% in the top 10%, well, that means 90th percentile. So look that up, and you're going to get 1.28 of a z-score. So 3.5 times 1.28 plus 48 equals 52.48 meters. And last but not least, what is the longest braking distance in the bottom 5%? So that's 0.0500, and we are looking less than, so that's negative 1.645. It's between negative 1.64 and negative 1.65. So again, 3.5 standard deviation times that z-score plus 48 equals 42.24 meters.